Please begin by completing your warm-up in your composition book. You will be placing these numbers in order from least to greatest. Pay close attention to the place values, the decimals, and whether they're negative, because that's going to indicate where they fall in the list. Here we see this display of powers of 10 again. Keep in mind this expression as it's written isn't considered a power of 10, but the piece at the bottom in the denominator is. We could rewrite this as 10 to the negative fifth, which would then be written as a power of 10. If we continue to get smaller and smaller, you can see we zoom in. And we'll begin to see DNA show up here in just a minute. There's that DNA strand. And as we move larger and larger, our exponent's going to get closer and closer to 10 to the 0 power. Remember, these are written as 10 with a negative exponent. There's that piece of rice and a popcorn kernel. And the speed at which these things increase in size is very rapid with each new power of 10. So we're going to complete this table as directed by starting with the first two rows. And it says the table shows an approximate measurement of various objects. I'm going to zoom in here so I have a little bit more space. To write 0.006 in unit form, we're going to write it with the word as we would say it. So this is 6 thousandths. Then for the fraction, that would be 6 over 1,000. We could write that as 6 times that fraction 1 over 1,000. Or we could write it using a power of 10 in the denominator, which would be 10 to the third for the thousands. Down here, this would be tenths, hundredths, thousandths, 10,000ths, 100,000ths, millions. Which would be 4 over a million. And we could rewrite that by taking the 4 and multiplying it by 1 over a million. And a million is a 1 followed by 6 zeros. So we could rewrite that as 4 times 1 over 10 to the 6th power. For problems 2 through 7, write the number in scientific notation or standard form as indicated in the table. So we've started with the number in standard form, and we're going to change it to scientific notation. Now this is a 7, and we have a power of 10. This is the tenths, hundredths, thousandths, 10,000ths. Which if we were to move that decimal, we would need to move it 4 spots to get it to where it is now, behind the 7. And so since this is a very small number, it needs a negative exponent, which could be written as 7 times 10 to the negative 4th power. Here, this one is also to the negative 4th power, so we're going to move that decimal 4 spots. Same thing here. There should be 3 zeros in front of it. Now this one is to the negative 6th. So we're going to move that 6 positions. You could also think of this as the millionths place. So tenths, hundredths, thousandths, 10,000s, 100,000s, millionths. So the 2 goes in the millionths place. This one, we have tenths, hundredths, thousandths, 10,000s, 100,000s, millionths. So the 6 goes in the millionths place. A million would be to the 6th power, but millionths would be the negative 6th power. Here that 3 is going to go in the 100,000ths place. Tenths, hundredths, thousandths, 100,000s, and then we fill in the rest. And we can check our work here. In class, we're going to do an activity where we are listing these numbers in order. So, for example, each group would have a number assigned to them, or each team, and we would be placing them in order from least to greatest across the room. However, since we're doing this digitally, we're going to discuss why these are placed in this specific order. We'll begin by looking at the magnitude, and the magnitude is the size of the number, or in this case, the exponents. Now, this one can be rewritten as 3.6 times 10 to the 0th power, because we don't need to move the decimal at all. When we look at the magnitude is the fastest way to figure out which ones are bigger. So I see here that we have a positive 4 and a positive 4. Now those are going to be the biggest two. Since they have the same exponent, or the same magnitude, we then get to look at the initial value. And since 7.02 is bigger than 6, we say that 7.02 times 10 to the 4th is the largest in this list. And the explanation is it has the largest magnitude and the biggest initial value. Now the next biggest order of magnitude is still that 6 times 10 to the 4th, because it has the next largest magnitude. And your book will describe that initial value that I talked about as the first factor. That's what they call it. So we've now taken care of the two largest. Let's look at the smallest. I see a negative here and a negative here. So those two are going to be the two smallest. If we're talking about the smallest of them, we want the smallest first factor. So 7 is bigger and 4.6 is smaller. So we're going to say that 4.6 times 10 to the negative second is the smallest, and 7 times 10 to the negative second would come next. This is the smallest magnitude and the smallest first factor. Next on our list, remember this has an order of magnitude of 0. So that one's going to come next because 0 is smaller than 2. Now between 3.2 times 10 to the second and 3 times 10 to the second, 3 would be smaller than 3.2. It's the medium order of magnitude or in the middle. And that takes care of all of them in our list. Now make sure that you have your workbook filled in and your warm-up completed, and then you're good to go.